Hello friends, in the last class we calculate the core diameter which is 114 mm for 100 kV transformer. Okay, now we are interested to calculate the step width of each core. Okay, so we know that transformer core is made up of laminations of having different widths, and we are taking the 9-step process, 9 step in the core. First step we are taking as 110 mm. Based on the core diameter, we are taking 110 mm, that we call as L1. And second step will be 105 mm. And third step will be 100 mm. And fourth step will be 90 mm. So like that, we are making all the 9-step process. One more important point is a minimum 5 to 10 mm width should be there from one lamination to other lamination. Minimum 5 to 10 we can keep. Okay, so based on that I made till 9-step process. I will laminate with this. Okay, so then we are trying to calculate the thickness of, we got the width of each one, right? Now we are trying to calculate the thickness of the stack, each width ka stack thickness. Like 110, if I take, how much thickness I have to put? It's not made up of only one layer, right? Some layers, group of layers, how much thickness I have to put, we have to know. Okay, so for that के लिए we are using the Pythagoras theorem. See, this is the, if you see from the top view, the diameter is, this is a D is a diameter, and this is right angle triangle, and this one is we call as K1, stack thickness. Okay, now this is length L1, and this also length L1. Okay, now we are taking the Pythagoras theorem. We are taking the Pythagoras theorem to calculate. So what, from this, K equal to under root L square minus D square minus L square. Okay, where D is the core diameter and L is the step width. First step I'm calculating. L1 I took as 110 mm, right? And K1, how to get? Under root D square minus L square. D is the core diameter, which we already know, 114 whole square minus L square. L is the length. Okay, so that is 29.93 mm. Next, first calculating second step, again apply Pythagoras theorem. Under root 114 whole square minus 105 whole square minus, very important one, we have to subtract this 29.93, this thickness from here. Why? Because we have to see, this is the other thickness, 105 mm wala will be like this. Okay, and this side also 105 mm will be there. So we have to subtract, if we calculate this diameter, core diameter D, if we subtract, and we will get complete thickness, right? We should subtract this from this K1, then we will get this and this thickness. Similarly, the same way we have to calculate, and we have to subtract these two thicknesses, this and this thickness. If we add, we'll get 44.39. We have to subtract from this, we'll get this one. Exact thicknesses of each width ka we are calculating. Okay, like this we'll calculate for 9-step process ka, 9-step process ka, and we will add all these K values which we got. We'll get as 106.75 mm. This is the total stack thickness of the core. Total stack thickness of the core. Okay. Now from that, this data we can calculate the core area also. Core area we are calculating. Core area one I showed. For L1 width I took. Area means length into width will be there for rectangle, right? So width you take as 110 mm, and core stack thickness which we got here is 29. First core ka 29.93 mm. Now I am multiplying these two to get area. Area is length into width. So we'll get this one. Like that we have to calculate all the 9-step process. 9-step ka. If you multiply, we'll get some all the things. After adding, we'll get total gross area is 9594.2 square mm we got. From the gross area, we'll calculate net area. Net area is gross area into stacking factor, and gross area is 9594.2 into stacking factor is 0.97. If we multiply, the total net area of the core, which for 100 kVA transformer is 9306.374 square mm. Okay, I showed a small diagram. See, this is a core stacks. Okay, they'll put middle will be like I told it. This is one total width is, this is 110. Is 110. Then 105, like that width will be there, and bottom also same thing. Exactly like mirror images. Top and bottom will be same. Okay, these all things we will design, and next class may we will design. We'll talk about some more winding resistance calculation. Vagera we will see the next class. Thank you.